the exam night revision for the math exam. It is 70 minutes, pencils are allowed, exam questions are MCQ and matching with 5 choices for every question. Example, a power 0. Anything power 0, you can just solve it without looking at the choices, solve it first. A power 0, anything power 0 is just 1. Where is the choice? B. So we'll just select B. So this is the correct answer. Anything else is not correct. You must select all the correct answers on Classera. Answer sheet will be submitted so you can write steps in it. The revision I divided into 4 parts. Part 1, Module 1, Part 2, Module 2, Module 7, and the geometry, the last part. Module 1. We want to write all the names that apply to each number. This is a matching question. You can have like this: A, B, C, D. And we want to match each number with the correct position. A, B, C, or D. Square root 9. What is the square root 9? 3. 3 is positive without a decimal, so it's a whole number. Let's remember this diagram first. The whole numbers are only positive and they must have no decimals. Integers, it's also no decimals, without any decimal. But what's unique here in the integers that it can be positive or it can be also negative. Rational number is any number that can be written as a fraction. So rational number is any number that can be written as a fraction. Irrational number, non-perfect squares like root 3, like pi. Pi is 3.14 and a lot of numbers. They are not repeating. 3.1457 and a lot of other numbers. So it is non-repeating, non-terminating means non-stopping, so it is irrational. What if it's a repeating decimal? It's a rational number. For example, 0.3 repeating is the same like 3 over 9. Simplify, divide by 3 up, divide by 3 down, so it is 1 over 3, and 1 over 3 is a fraction. Any fraction is rational number, so we can say that the repeating decimals is also rational number. What if it is 0.45 repeating? It is the same like 45 over, remember the 4 steps? It will be 45 over 99. Divide by 9 up, divide by 9 down. 45 over 9, 5. 99 divided 9, 11. 5 over 11 is a fraction, so we can say that 0.45 repeating is a rational number. Very good. So root 9, which is 3, it is a whole number. Any whole number is considered also an integer, because integer is the bigger family. Integer, any integer is also considered rational, because any integer is considered rational and rational is the bigger family. Any rational number is also a real number. So 3, 0, 1, 4, 5, whatever it is 257, like the next question, it's also a whole number, and any whole number is integer, any integer is rational, and any rational is also real. Root 50, it is an irrational number because it's non-perfect. I don't have a number by itself gives root 50, so we can say that root 50 is irrational, and any irrational is also real. Any irrational is also real. I have another square root here. This one, root 50, it was irrational. Root 16 is 4, because 4 times 4 is 16. And 4 is a positive, no decimal, so it's whole number. Any whole is rational. Any whole is integer. Any whole is integer. Any integer is rational. And any rational is also real. Very good. Mixed number, 2 times 8, 16, plus 1 is 17. So it is 17 over 2. Can I simplify more? No, it's not divisible by 2, not divisible by 2. So 17 over 2 is rational, it is a fraction. So this is C. Any rational is also at the same time real. 16.6. What is 16.6? It has a decimal, so anything that has a decimal and repeating or non-repeating like this is rational because it can be represented as a fraction. 166 over 10. So this is a rational number, C. Any rational is also real. Very good. Write each fraction as a decimal. We want the fraction to be decimal, and we want the decimal to be as a fraction type. Fractions to be decimal, long division. 7 divided 20. 7 divided 20, 7 is smaller, can't be. 0, decimal point, 70. 70 divided 20. How many 20s are in 7? In the 70? We have 3, because 3 times 20 is 60. Subtract 10. 10 divided 20 can't be. Drop a 0. Becomes 100. 100 divided 20 is 5. 5 times 20, 100. So now it becomes 0.35. 1.27 repeating. 27 repeating is the same like 27 over 99. Because you have 2 digits after the decimal point. The whole number as it is, the 1. Simplify. 27 and 99 are divisible by 9. 27 divided 9, 3. 99 divided 9, 11. So it is 1 and 3 over 11. Mixed number. 8 times 1, 8. Plus 7. 8 times 1, 8 plus 7 is 15. 15 over 8. Long division to make it as a decimal. 15 over 8. How many 8s in the 15? I just have 1. 1 times 8 is 8. Subtract, it is 7. 15 minus 8 is 7. 7 divided 8 can't be. Decimal point, drop a 0. 70 divided 8. The nearest number to the 70. 8 times 8 is 64. So we'll put 8. 8 times 8 is 64. Subtract. 70 minus 64, 6. Borrow. 0 minus 4 can't be. So borrow. 10 minus 4 is 6. 6 minus 6 is 0, so it's just 6. 60. I dropped another 0, so 60. 60 divided 8 is 7. 7 times 8, 56. Subtract. 60 minus 56 is 4. Drop a 0. 40 divided 8 is 5. 5 times 8 is 40. Subtract. It will be 0. So the answer is 1.875. Very good. Solve each equation for x. X squared is 81. The choices will be 9, negative 9, positive or negative 9, 0, and E, he might say none of the above. What is the correct answer? This is the idea. Square root left, square root right. Whenever you want to cancel the power 2, you should square root. Put a square root for the left, square root for the right. Power 2 will cancel with the root. So x is equal, positive or negative, root 81. Which is positive or negative. What is the number that I multiply by itself gives 81? It is 9. 9 times 9 is 81. So the correct answer is positive or negative 9. Now he's asking about cubic root. Take care. This was square root power 2. This is cubic root. It is power 3. So the same idea. And instead of square root, it will be cubic root left, cubic root right. Power 3 will cancel with the power 3. Root 3 will cancel with the power 3. So this is x equals what? This is the question. Something times itself is 343. What would this number be? It is 7. Why? Because 7 times 7, 49. 7 times 7 is 49. 49 times 7, let's see. 7 times 9 is 63. 3 and carry out 6. 7 times 4, 28. 28 plus 6 is 34. So the answer is 343. So cubic root 343 is 7, because 7 times 7 times 7 is 343. X squared equals 1 over 100. Square root left, square root right. Power 2 will cancel the root. X equal positive or negative root 1 over 100. Positive or negative 1 over 100. What number by itself gives 100? It is just 10. 10 times 10 is 100. 1 times 1 is 1. So the answer is X equal positive or negative 1 over 10. A square patio. I have a square patio, which means that all the sides are the same. And here he is saying that the area is 200 feet squared. And he is asking about each side of this patio. We know that the area is equal to side by itself, side times side. Side times side is the same like side squared. So area is 200, side times side, side squared. So now you know that side squared is 200. If you want to get the s or the side, square root left, square root right. Power 2 will cancel the root. S equals positive or negative root 200. Positive or negative root 200. What is root 200? This is the question. But the question now is, can the side be negative? No. So if we said that it can be positive or negative, actually the negative solution is refused, because I have no sides for a square that can be negative. No sides can be negative. So the negative answer is refused. So now it is side equals root 200. What is root 200? Estimate. Root 200. Upper estimate, lower estimate. What is the perfect square above 200? It is root 225. How did I know? Because 15 times 15 is 5 times 5, 25. 5 and carry up 2. 5 times 1 is 5 plus 2 is 7. Put the 0. 1 times 5 is 5. 1 times 1 is 1. Add 5. 7 plus 5, 12. 1 and 1 is 2. So it's 225. So square root 225 is just 15. What would be the lower estimate? It might be 14. 14 times 14, let's see. 4 times 4, 16. 6 and carry up 1. 4 times 1 is 4, plus 1 is 5. Put the 0. 1 times 4 is 4. 1 times 1 is 1. So add 6. 5 and 4 is 9. 1. So 196. Square root 196. Which is estimated to be 14. So now the number is between the 14 and the 15. 200 is closer to 125 or closer to the 296? Actually, it is close. It's close to 196 because it is just 4 steps away from 196. So we can say it is by estimation it is 14. Actually, it is somehow close. So 14.3 or 14.2. This is the estimation of this side. So 14.3 feet. Write all names that apply to each number. 121 over root 121. It is 121 over square root 121. What number by itself is 121? It's 11. 11 times 11, 121. So square root 121 is just 11. Divide 121 over 11. 121 divided 11 is equal 11. So 11 is positive, no decimals, so it's a whole number. Any whole number is integer. Any integer is rational. Any rational is also real. Pi over 2. Mister, it's a fraction, but take care, pi is irrational. So the answer is irrational. And it's also real. Again, this part, it's a fraction. We should have said it's rational number, but is this an integer? No. So pi is irrational, so the answer is irrational and real. Tell whether the statement is true or false. All integers are rational numbers. Yes. Yes. All integers are rational number because 3 is an integer. This is an example. And 3 can be written as a fraction. 3 is equal to 3 over 1. So 3 is also rational number. Very good. Selected response. The square root of a number is equal 9. What is the other square root? We said that square root x is equal 9. The other square root is negative 9. Square root 15, 5 plus 11. Compare it with 5 plus root 11. Estimate root 5. How do we estimate root 5? 2 times 2 is 4. 3 times 3 is 9. We have the 5 lying here in between the 4 and the 9. The 5 is lying between the 4 and the 9. So the upper estimate is root 9. The lower estimate is root 4. Root 11. You also have upper estimate, lower estimate. 3 times 3 is 9. 4 times 4 is 16. So the 11 is here in between the 9 and the 16. The upper estimate is root 16. The lower estimate is root 9. Root 16 is 4. Root 9 is 3. We are estimating the root 11 and we are estimating the root 5. Root 9 here is 3. Root 4 here is 2. 5 is closer to the root 4. 5 is closer to the 4. So it is 2.1 because it is very close. So root 5 is 2.1. 2.1 plus 11, this would be 2.1 plus 11. 11 is the same like 11.0. Add 1 plus 0, 1. Decimal point. 2 plus 1, 3. So it is 13.1. 5 plus root 11. Estimate root 11. 11 is closer to the 9. 11 is 5 steps away from 16. 11 is just 2 steps away from the 9. So it is closer to the 9. So we can say it is 3.2 maybe. So this is 3.2 plus the 5. 5 plus 3.2. 3.2 plus 5. 5 is the same like 5.0. Add 2 decimal point 5. So this is 3 plus 5 is 8. So this is 8.2. Which is bigger? 13.1 actually is greater than 8.2. Order. He is asking you to order from least to greatest. Estimate root 99. Upper estimate root 100. Why? Because 10 times 10 is 100. 9 times 9 is 81. 99 is in between 100 and 81. So here is root 81. Root 100 is 10. Root 81 is 9. 99 is very close to 100. So this is 9.9. Root 99 is between the 9 and 10. So we say that root 99 is 9.9 because it is very close to the root 100. So this is 9.9. Pi squared. What is pi squared? Pi squared is the same like 3 or pi times pi, which is equal to 3.14 times 3.14 because the pi is equal 3.14. Multiply. 4 times 4 is 16. 6 and carry up 1. 4 times 1 is 4 plus 1 is 5. 4 times 3 is 12. Here you have 2 decimal places, 1, 2. And here you also have 2 decimal places, 1, 2. So the answer we have just finished. The answer should have 4 decimal places. So now I'm done with the first number. 4 times 4 is 16, 4 times 1 is 4, plus 1 is 5, 4 times 3 is 12. Continue. I will move on to the 1. Put the 0 first. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Move to the 3. 3 has 2 places before it, so 2 zeros. 3 times 4 is 12. 2 and carry up 1. 3 times 1, 3. Plus 1, 4. 3 times 3, 9. Add 6. 5 and 4, 9. 2, 1, 2. 3 plus 2 is 5. 1 plus 3 is 4. 4 plus 4 is 8. So it is 9, 8, 5, 9, 6. And we said the answer must have 2 and 2, 4 decimal places. So 1, 2, 3, 4. So the answer is 9.8596. 9.8596. This is the pi squared. What about 9.8 repeating? Is the same like 9.888 and so on. So now let's order them. Where is the least of them? Actually, 9.85 or 9.88? Yes, 9.85 is the least. So pi squared. Okay, 9.8 repeating or 9.9? Actually, 9.9 is greater than 9.8. So the least is 9.8 repeating. And the biggest number is 9.9, which is root 99. Root 1 over 25, 1 over 4 is 0.2 repeating. Square root 1 over 25. A number by itself is 25, so we can have it as 1 over 5. So this one is 1 over 5, because 5 times 5 is 25, 1 times 1 is 1. 1 over 5 is the same like 0.2 using the long division. 1 divided 5. Can't be. 0, decimal point. 10. 10 times 5 is 2. 2 times 5 is 10. So the answer is 0.2. 1 over 4 also, you will do long division. 1 divided 4. 1 divided 4 can't be. 0. 0 times 4, of course, can't be. Decimal point. 10. 10 divided 4 is 2. 2 times 4 is 8. 2 times 4 is 8. 10 minus 8 is 2. Drop another 0. Drop another 0. 20 divided 4 is 5. 5 times 4 is 20. And the answer is 1 over 4 is the same like 0.25. 0.2 repeating is the same like 0.222 and so on. Order the least to greatest. This is 0.2 as if it is 0.20. The least of them is root 1 over 25. Next, you have the second thing is 0.22, which is 0.2 repeating. And then 1 over 4 is the largest because there is a 5 here. So again, 20, 22, 25. Root 1 over 25, 0.2 repeating, 1 over 4. What number is shown on the graph? In this question, we want to solve it in details. Pi is the same like 3.14 plus 3. Let's add 3.14 plus 3. 3 is the same like 3.0. 4 plus 0, 4. 1 as it is. Keep the decimal point. 3 plus 3 is 6. So it is 6.14. So if this is 6.2, here is 6.1, 6.14 would be here. So this is A. But what about B? Square root 4 is 2. 2 plus 2.5 is 2, is the same like 2.0. 0 plus 5 is 5. Decimal point as it is 2 plus 2 is 4. So this is 4.5. Actually 4.5 even is before the 6. So here is B. He is asking about the decimal point. Root 20. Let's estimate root 20. Upper estimate, lower estimate. We know that 5 times 5 is 25, 4 times 4 is 16. So 20 is here in between the 16 and the 25. Lower estimate, root 16. Upper estimate, root 25. Root 25 is 5, root 16 is 4. 20 actually is close to the 16, it is close to this. So we can say it is 4.4 maybe, but actually it's estimation, so it's maybe 4.4, 1, 2, 3, and so on. So 4.4, 1, 2, 3, and so on maybe, plus 2, add the whole numbers together, 2 plus the 4 is 6. Point, keep the decimal part as it is, 4, 1, 2, 3. So where is this on the number line? Actually it is after 6.4, so we can say that the correct answer here is C. What about the last one? 6.14 repeating, 6.14, 14, 14, and so on. Actually it is less than 6.2, so again C, D is before 6.2 because 6.14 is less than 6.2. Next, which statement is false? No integers are irrational, all whole numbers are integers, no real numbers are irrational type. Let's think of it. He is asking about the false statement. No integers are irrational, correct? All integers are rational. It's not irrational, so this is correct. All whole numbers are integers. Of course, any whole number is an integer. Any integer is rational. Any integer is rational. Any rational is real. How do I know? I draw a diagram. Not to get confused in the exam, I draw a diagram. Here is the whole, here is the integer, and also I have the rational, and on the other side I have irrational numbers. So step by step, no integers are irrational. Yes, all the integers are rational, so this is correct. All whole numbers are integers. Yes, all the whole numbers are inside the integer, so this is also correct. No real numbers are irrational. The real numbers, take care, it is irrational and rational. So this is false, and this is the false statement that he is looking for, because real numbers can also be irrational numbers. All integers greater than 0 are whole numbers. Yes, this is true. For example, 2, 5, 7, all of them, they have no decimals, they are positive, so they are also whole numbers. Which of the following is an integer but not a whole number? Which of the following is integer but not whole? Which means integer means no decimal. Integer means no decimal. Okay? Not a whole. Whole means positive and no decimal. خلاص? طيب. Let's see together. Negative 9.6. Actually, it is an integer? No. We want first to look for the integers. So this one is not an integer because it has a decimal. This one is also not integer because it has a decimal. 0 and negative 4. Yes, this is an integer, and this one is also an integer. It's negative, but it has no decimal. So the question now is, we want the one that is not a whole number, that is not positive, which is the negative 4. Negative 4 is negative. It's a negative number, so it can't be a whole number. Thank you so much. We are done with part 1 and module 1. In the next video, we will start module 2, inshallah. Thank you so much. This is Mr. Mahmoud. Thank you.